Hey, 42 here. Everyone knows the phrase, red sky at night, shepherd's delight. Red sky in the morning, shepherd's warning. The idea is that a red sky in the evening heralds fine weather the next day. But a red sky in the morning is a portent of overcast misery, rainfall, and all around bad weather. The phrase may be old, but it's surprisingly accurate. Also known as sailor's delight or pink sky at night, it first appears in the Bible, specifically in the New Testament book of Matthew, so the proverb is at least 2,000 years old. Jesus is recorded as saying, "When it is evening, you say, it will be fair weather, for the sky is red. And in the morning, it will be stormy today, for the sky is red and threatening." And whilst Big J was using this as an analogy to explain to his followers their inability to interpret the signs of the times, there is actually significant merit in using the colour of the morning and evening sky to forecast weather. A red sky occurs when high pressure traps small particles and dust in the atmosphere. This interferes with blue light, scattering it and leaving only the red light shining through. Hence the red sky. As this high pressure is happening during the evening, towards sunset, it typically means that the next day will be warm and pleasant. I will explain why high pressure creates warm weather soon, but for now, just remember that high pressure equals red sky equals fine weather. The reverse scenario, where the sky is red in the morning, means that the high pressure weather has already passed for the day, and the sun is reflecting off rain clouds, which means you're probably in for some low pressure rain and misery. This adage is remarkably accurate, and it isn't the only rhyming weather saying we have. There's clear moon, frost soon. When dew is on the grass, rain will never come to pass. Mackerel skies and mare's tails make tall ships carry low sails. Rain before 7, fine before 11, and many more. In short, humans are obsessed with inventing silly sayings to predict and attempt to rationalize the weather. And it's really no surprise. The weather is one of the most decisive forces in our lives. We eagerly anticipate summer. It's one of the first things we check in the morning. It can affect mood and rate of depression. If you're a kid at school, snow can be a lifesaver. Cyclones and hurricanes can end our lives. And if you live in England, anything other than soul-destroying grey is something akin to an act of God. And the Scottish still think the sun is an urban legend. In fact, in the past, people attributed the weather to exactly that, the acts of God, or rather, gods. Appearing incessantly through polytheistic and monotheistic religions alike, humans have sought to influence the weather by praying to Thor, Marduk, Horus, Yahweh, Zeus, Vayu, Indra, Rajin, Yushi, Talok, and others, often accompanied by complex and sometimes brutal rituals. And you probably pray to the weather gods each day, without even realizing it. Many of us proclaim, "God, I hope it doesn't rain today," or "God, I hope we have a nice summer." Whilst it's a step down from cutting someone's heart out and slapping it on an altar to please Talok, it's in the same ballpark. But hey, if you really need a sunny day tomorrow, you could always try giving that old school option a go. The age-old perception of weather as a physical manifestation of divine power makes sense. As intelligent as human beings are, the weather, in many ways, represents a godlike force and influence over our lives. Of all the natural world's phenomena, the weather is perhaps the most obvious example of Mother Nature's awesome, unbridled, uncontrollable power. But before I delve into the world-ending catastrophes we all know and love, I need to explain how we actually arrive there in the first place. How exactly does a light sprinkle become a tornado? And to do that, I need to commit the worst social sin of all time. I need to talk about the weather. Firstly, what is the weather? Well, the term weather describes the temporary conditions of the atmosphere, which is the layer of air that surrounds the Earth, composed of nitrogen, oxygen, water vapor, carbon dioxide, farts, and argon, and it makes up the air you're breathing now. The atmosphere serves as a gaseous barrier between our planet and the endless universe beyond. Our planet has a gravitational pull, is bombarded with sunlight and intergalactic ultraviolet radiation, and has topography ranging from oceans to enormous mountain ranges. each being an element which influences our atmosphere, its cycles of air, and how the weather behaves. One of the most crucial concepts to grasp about the weather is that it's all interconnected. It's a single, contiguous global system. What's normal for your part of the world, such as the frigid winds of Alaska, is intrinsically linked with and can affect other weather systems all around the globe. There's an old adage that goes something like this: if a butterfly flaps its wings on one side of the world, it can cause a tornado on the other side. It's not actually true, but the butterfly effect, as it's known, is a nice introduction to chaos theory and how tiny variations in a large, complex, and ostensibly chaotic system can sometimes cause enormous changes elsewhere in the system. And the global weather system is a chaotic system, and that means that seemingly insignificant factors like temperature in Delhi reaching a degree higher than expected for an hour can cause it to rain in LA the following day. Or it might do absolutely nothing. Thus, weather has a huge amount of inherent randomness, and this is why, despite supercomputers and decades of research, we are still unable to predict it with a high degree of accuracy. Like a gunshot that echoes far beyond its point of origin, the weather in your region has a reach of hundreds to thousands of miles. This is why storms that start their life hurting nobody in the Atlantic eventually end up tearing through the Caribbean towards Florida. Likewise, the region of Earth you call home has its own localized weather patterns. For example, Egypt is dry and extremely hot, whereas cities like Medellin, Colombia, exist in a state of near-perfect weather all year round. Hence the name La Ciudad de la Eterna Primavera, which literally means the city of eternal spring. I guess that makes Australia El País del Eterno Cáncer de Piel, or the country of eternal skin cancer. Each region of Earth has its own unique climate. Contrary to weather, which can turn on a dime, an area's climate stays the same. Climate being the typical weather conditions over a long period. An area's climate can change, but it takes hundreds to thousands of years. For example, Egypt's Sahara Desert is known for being arid, endless sand. But thousands of years ago, it used to be quite green, rainy, and home to some impressive lakes. The 5 main climate types on Earth are tropical, dry, temperate, continental, polar. But there are several subclimate types within each of these, such as subarctic and rainforest. The tilt of the planet itself is what creates the seasons. Planetary tilt increases the amount of solar radiation countries get during certain periods of the year, because the sun's rays are spread unevenly over the surface depending on where they hit the Earth, resulting in seasons that range from hot summers to cold winters, or, if you're based near the equator, hot all year round, with bouts of intense rain, followed by heat during the spring and autumn equinoxes. Equinoxes being, if you don't know, a period when it's light and dark in equal measure throughout the day. There are 6 main components that constitute what we laymen call the weather. These are temperature, atmospheric pressure, wind, humidity, precipitation, and cloudiness. Temperature is quite simply the measure of how hot the atmosphere is, measured in Celsius or Fahrenheit, depending on how you pronounce tomato. Atmospheric pressure, however, is a little bit more complicated. The atmosphere is believed to have originally escaped from the planet itself, formed in the heat of radioactive decay and spewed out by volcanoes, which is about as awesome as it sounds. Although originally filled with poisonous, unbreathable air, over roughly 1 million years it was slowly infused with oxygen and transmuted into the refreshing tonic that we now enjoy. Although it's worth mentioning that, global warming aside, this is probably not the final form of our planet's atmosphere. The atmosphere is held in place by gravity, even though it thins out into nothingness 60 miles above sea level. Although most of the weather you experience, such as clouds and wind, are contained within the first 20 miles. It weighs 4.99 quadrillion metric tons, which sounds like a lot, and it is, but the Earth itself weighs about 1 million times that. But the weight, or more accurately, mass of the atmosphere, is what causes air pressure. Even though a handful of air is virtually weightless, it has overwhelming mass when you take a huge chunk of it. And if you were to hold out your palm, you would, in essence, be supporting a 60-mile-high column of air that stretched out into space, weighing several tons. This weight means that the majority of the oxygen-rich air is below a 3-mile altitude, because air pressure pushes down on the air below it, making it denser and thus more full of oxygen per breath. This is why when you go up a mountain it's more difficult to breathe. Less weight, less pressure, less oxygen. There are 4 layers to the planet's atmosphere. The troposphere, which is where the entire planet resides. The stratosphere, which contains the ozone layer. The icy cold mesosphere. And mesopause, not to be confused with the menopause, which is something quite different. The low density but searing hot thermosphere. The temperature here reaches 2,500 degrees Celsius. But if you were to hang out there, you would actually feel very, very cold, because there aren't enough air particles to transfer that heat to your body. And finally, the exosphere, which extends into space. These varying layers of atmosphere are governed by the weakening gravity and varying pressures that affects the molecules within. As temperature increases, the molecules move around more, causing torrents of vertical air currents. As the air becomes less dense, it moves into cooler regions, becoming denser, and sinks back down again into hotter regions. It's an endless cycle. This is why the air feels thicker in tropical countries and thinner near the cooler poles. Convection is a fancy way to describe all of this. An area where this happens is called a convection cell, where the movement of gas, in this case air, is present. These convection cells are littered all over the planet, causing movement of air from areas of high pressure to low pressure, influenced by the Coriolis force. The Coriolis effect is when a ball spins, i.e. planet Earth, and all free-moving winds in the northern hemisphere are deflected to the right or counterclockwise, and in the south to the left or clockwise. The cause of the Coriolis effect is because the Earth spins faster at the equator than at the poles, so there's a natural distortion of air currents on the vertical axis as they bend around the Earth's moving surface. This is a slightly confusing concept to wrap your head around, but just remember, north of the equator, storms spin counterclockwise and clockwise south of it. Humans even have an impact on winds. When Chicago was purposely rebuilt by city planners in a structured grid, the frigid wind coming in from Lake Michigan was forced into narrow channels, causing it to gain in speed and strength. Hence, the Windy City. Humidity is something everyone who's travelled to a country near the equator has experienced. Humid environments are hot, muggy, there are mosquitoes everywhere, it feels about 10 degrees hotter than it is, and you leave the shower sweatier than when you entered. No, I don't like it, and I don't see why anyone would. The reason humidity is so unbearable, thick and muggy, is that it describes the amount of water vapour in the air. And the more water vapour present, the less effective your body's sweat becomes. So you're unable to cool down no matter how hard you try. When the air in a cloud has a relative humidity of 100%, it can no longer hold any water and it begins to fall to the ground as rainfall. This is part of the hydrologic cycle, where water continually cycles from sea to the air to the land and back again. Cloudiness is a huge part of this precipitation phenomenon. You might wonder why you can see clouds but not the water vapour itself. Why aren't humid countries one giant cloud? How is that possible if they're made out of the same substance? Well, the air is actually full of tiny dust particles called condensation nuclei, which come from everywhere from volcanoes to pollution. When water condenses onto trillions of these microscopic nuclei, brought together by cold temperatures, clouds are formed. So basically, clouds are dusty water. Delicious. But what about storms, tornadoes, and hurricanes? Well, to explain these phenomena, we first need to have a quick chat about weather systems. And look, give me a break. You clicked on this video, not me. It's the weather, not a breakdown of the greatest gladiator fights in history. Actually, that would make a good video. Watch this space. Anyway, weather systems simply describe the movement of hot and cold air around the planet. These movements are split into high pressure and low pressure systems. High pressure systems keep cool, dry air rotating and stop moisture from rising into the atmosphere. The result is that they usually keep the sky nice and clear. A low pressure system, on the other hand, keeps warm, moist air rotating and brings storms with it. These systems pass through the mid points of the planet, known as mid-latitudes, halfway from the equator and one of the poles. The result is that weather in these regions is constantly changing and can switch from calm to psychopathically violent in minutes. So if you're ever wondering why the weather in your part of the world seems to have schizophrenia, consider consulting a map. Storms are caused by enormous air masses racing around the world and smashing into one another, the weather equivalent of a barroom brawl. Some of these storms become thunderstorms. There are 2,000 thunderstorms happening at any one time across the world, and this results in 44 lightning strikes every single second. Thunderstorms are caused when a cloud gets too jacked up for its own good. They start the same as other clouds, but turn into tall, cumulus clouds. When this cloud reaches about 40,000 feet up into the troposphere, it gets pumped up on raindrops and ice crystals, then gets too big and comes crashing back down, dragging all the water mass with it. This creates an incredibly strong downdraft, sending torrents of wind in all conceivable directions. As for the thunderous crack that follows, that's the result of a flash of lightning heating the air to 30,000 degrees Celsius. Making the air expand so rapidly it forms a shockwave that breaks the sound barrier. Lightning is formed by ice crystals high up in the cloud colliding with each other millions of times per second, and thus creating a static charge, which eventually releases as electricity. You will always experience the flash before the boom because light is faster than sound, so it reaches you sooner. But they actually happen at the very same time. In short, imagine a fat guy leaping into a pool screaming "Cannonball!" and you've got a thunderstorm. In less than 1% of thunderstorms, something even more destructive than thunder and lightning happens. A tornado forms. A swirling vortex of air, or multiple suction vortices that promise to destroy everything in their path. Scientists aren't exactly certain on how tornadoes come to be, but it is thought that powerful updrafts are one of the causes. What is known, however, is how destructive they can be. The deadliest tornado in history was the Dalatpur Satarya tornado, which caused the death of approximately 1,300 people on its own. In fact, Bangladeshi tornadoes are some of the most destructive on Earth. 19 of them have killed more than 100 people, totaling almost half of the entire world's tornado deaths. But there is one type of storm that dwarfs the power of any tornado, and that's the hurricane, the bad boy of the storm world. Also known as cyclones or typhoons, hurricanes are low-pressure zones that spin wildly out of control, gaining rapidly in speed and size. They form a huge column of swirling death that ascends into the sky, spawned out of swathes of surface winds sucked in by the low-pressure zone. On the inside of the column of fury is a relative patch of peace, called the eye of the hurricane, or the eye of the storm. This warm air downdraft is actually quite pleasant, but the outside of it is anything but. Reaching wind speeds of over 74 miles per hour and sizes in excess of 600 kilometers, these enormous storms are the most destructive forces on Earth. Sending wind at you so powerful, it's like you've just walked in front of an 18-wheeler on the motorway. These storms leave entire towns, cities, and countries ravaged by destruction, kill thousands of people, and cost billions of dollars in property damage. Hurricane Katrina, for instance, cost around $125 billion in nominal damage and caused the death of up to 1,800 people. So, whilst you may enjoy the thrills of thunder and lightning, or watch tornadoes from a safe distance, if a hurricane is on the way, get the hell out of there. Unless you're in the centre, of course. Then you can prop up a nice little reclining chair, put an umbrella in your mojito, and enjoy the show. But don't get too comfortable, because hurricanes move fast. But aside from death and misery, the weather also has some interesting and bizarre optical effects. For example, the sky is blue because light, which contains all wavelengths of colour, is scattered by the dust and water molecules in the atmosphere. Blue light, travelling as a shorter, smaller wave, gets scattered far more, hence blue sky. Later in the evening, however, these beams of blue light reduce in intensity, resulting in yellow, orange, and red light across the evening sky. When the sunlight passes through raindrops, the light is bent and a rainbow is formed, which you already know well. But did you know they can even appear at night and are quite literally called moonbows? You'll struggle to see them with the naked eye, but use a camera with a long enough exposure time and its majesty will be revealed. But there's also halos, coronas, parhelions, crepuscular rays, circumzenithal arcs, northern lights, and even their lesser known siblings, the southern lights, aurora australis, all illusions of light created by the sun, the atmosphere, and the weather. Well, there you go. With your shining new knowledge of complex weather systems, you can blow away your friends as you rain down facts upon them, and you'll no doubt be met with thunderous applause. Thanks for watching. If you enjoyed this video, then please consider supporting me on Patreon because it really helps me to continue to make them. You can find the link in the description. Also, you can get your hands on a first edition signed copy of my new book, Sticker Flagging It, by heading on over to Unbound Publishing and pre-ordering your copy today. Thank you.